All right, so picking up where we left off, let's look at example 4. We have 1 over t squared plus 8 over t plus 15 equals 0. So we want to solve this equation. It's a rational equation, ratio fractions. We want to build the least common denominator. So investigating the denominators, we have t squared, t, and 1. So the least common denominator would be t squared. No sense in multiplying t times t squared and getting t cubed, because if I multiply by t squared, that will cancel both of these denominators. So I'm going to rewrite the problem and multiply by the least common denominator. Alright, the least common denominator is t squared, so we'll go ahead and make that a fraction. We'll disregard the 1 when we multiply by 15. Show that you're going to multiply by all the terms in the equation and even the 0. Alright, focusing on this first product right here, go ahead and divide out what you can. So the t squareds will cancel. That'll leave you with 1. That's convenient. Plus, alright, focusing on this next product of 8 over t times t squared over 1, you can divide out a t here and a t here, leaving t in the numerator. So t times the 8 that's there present would be 8t, plus, and then t squared times 15 would be 15t squared, equals that product over there would be 0. I'm going to go ahead and rearrange this in descending order for the variable t. Okay, so the resulting equation is quadratic. Thinking about our previous work, we can solve by factoring, completing the square. Nope, that's out. Extracting roots is out. And quadratic formula. I'm going to try and see if it'll factor. So we're going to quickly produce our multiply add chart. So it has to multiply to a times c, so that would be 15. And it has to add to 8. So let's look for factors of 15 that might possibly add to 8. I think that's going to be 3 and 5. Yep, 3 plus 5, that's a comma, is 8. So looking at this equation here, I'm going to have to factor by grouping. So keep the 15t squared. Rewrite 8t as the sum of 3t and 5t. And since they're both positive, it doesn't matter the order. If I had a negative 1, I'd put it up front, or first rather. Keep the plus 1. Rewrite the problem so I can put in my parentheses. Group, 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 group. Well, I don't know what happened here. The pen's just tired. Again, it's 3 hours in. Alright, common factor is 3t, leaving 5t plus 1, plus, and then over here we have an understood factor of 1, so we'll put that up front because we need to use that. Alright, and then we're going to be able to complete the factoring. One binomial will be 5t plus 1, and the other binomial will be 3t plus 1. Solve by setting each factor equal to 0. Subtract 1, divide by 5, t equals negative 1/5. Subtract 1, divide by 3, t equals negative 1/3. Of course, we do want to check both the solutions, so when you plug in negative 1/5, it becomes kind of complicated with the check. I'll just let you know that I've checked them and they both work. That'll save us some time. Alright, getting near the end, 2 more examples. So we have 2 over x equals 3 over x minus 2 minus 1, rational equation. We're going to build the least common denominator. The least common denominator will be the product of these two different denominators. So it looks like we're going to have to build the LCD as x times quantity x minus 2. Let's put it over 1. We'll disregard the 1 when we multiply by negative 1 here. Show that you're going to multiply by all the terms in the equation. Alright, when we multiply these two fractions together, the x's will divide out, leaving 2 to be multiplied by x minus 2. That doesn't seem too cumbersome. I'm going to go ahead and distribute the 2 into x minus 2, and I'm going to end up with 2x minus 4. When I multiply these two together, the x minus 2's will divide out, leaving the remaining factor of x in the numerator to multiply by the x here. And then minus, and then it's 1 times that product, that LCD, so I end up with this. So I'm going to have to go through and distribute this negative x in my next step. So I've got 3x, and then distributing here it gives negative x squared and then plus 2x. Okay, looking at the resulting quadratic equation, I identify that this term right here is negative, so I'm going to go ahead and move it to the other side. But I do see that I can collect 3x and 2x maybe first, so I'll do that. So I end up with 5x minus x squared. Now I'm going to zero out the right side. So when I bring over negative x squared, I have positive x squared. When I bring over 5x, I have negative 5x to collect with 2x, and 2x minus 5x would result in minus 3x and the minus 4. Alright, can I factor this quadratic? I think so. I have to multiply and get negative 4, but add to negative 3. So 1 and 4 or 2 and 2. But one of the two have to be negative. It looks like if I make the 4 the negative, I sum them, I'm going to get negative 3. So I don't have to factor by grouping because a is 1. I can go straight to a binomial times a binomial. So it has to be x and x. And it looks like plus 1 and minus 4. Set each factor equal to 0 and solve. I'm going to wait to box it because I think I need to check it. I'm going to wait to box it because I need to check it. This wouldn't be too difficult to check, so if I plug in negative 1, that's negative 2. So keep that on hold in your brain. This is negative 2. If I put in negative 1 here, that would be 3 over negative 3 or negative 1. Negative 1 minus 1 would be negative 2. So this one does check. I know that's kind of quick. Plug in 4. That results in a half. Plug in 4, and that would result in 3 halves minus 1, which is a half, and that's what we got on the left side. So that does check too. Almost there. Last example. Hopefully by now you're getting the hang of it though. No, I can't have 2 equals. Give me a second, let me check this one. Alright, so double checking. This is not an equals over here. This first one's not. It's actually a plus. So let me get rid of that. Okay, so I think we're good. This is going to be a plus. Equals a negative 3. Alright, building the LCD, that's going to be the product of x and quantity x plus 3. Alright, this first product, the x's divide out, leaving 4 to be multiplied by x plus 3. I'll go ahead and distribute that. That's not too bad. 4x plus 12 plus, in this next product, the x plus 3's will divide out, leaving the x in the numerator to multiply by 2, so that's plus 2x. So I have to come back and collect these. Equals, and we've got negative 3 to multiply through all this. So I've got negative 3 with the x times the quantity x plus 3. So we'll do that work in the next step. So cleaning this up, we're going to have 6x plus 12 equals, it looks like negative 3x squared minus 9x. And like the previous example, we're going to zero out the right side. So bringing this over here, we're going to have positive 3x squared. Add 9x to 6x, that's 15x, and then the plus 12. Alright, so we've got a quadratic equation. You know, this hasn't come up before, but if you look at this quadratic equation, let's go ahead and divide out the 3. Take out that GCF. What it did for us, it made this trinomial have, at least had the a value is 1, so that's nice. So we can kind of put 3 on hold, leave it there. It's part of the problem, but let's just focus our attention on that trinomial. Are there factors of 4 that add to 5? Yep, 1 and 4. So I'm going to keep the 3. I don't have to factor by grouping. That was kind of nice. This is x and this is x. And I'm going to have a plus 4 and a plus 1. So either the 3 is 0 or either one of these two factors is 0. Well, we know 3, if you set it equal to 0, is not a true statement, so that's not equal. So our work is a little bit easier. If I check negative 4, that would be negative 1, negative 2. Yep, that works. And real quickly, let's see if we can check negative 1. So that would be negative 4 plus 1 is negative. Yep, that works too. I know those were quick checks, but I wanted to kind of save some time. Alright, so we found all the solutions. We were sure to check our answers, and we are done.